Alright, this physics video is for Tuesday/Wednesday. And I should get a timer, so hold on. Alright. What we're going to look at, I had mentioned that while I was away, we would do electricity, but since we needed to have time to do that test/worksheet, I think I'll just go on straight through. I really don't have enough time in 2 days. I'll be back Thursday, so I don't have enough time to do a full chapter. And because the part of my travels ended up on the weekend. So I think I'll just go straight on to the next topic in our book. So I don't have a paper to hand out to you, but if you want to set it up, take a piece of paper. And this is mod, what is this? This is mod 11, and it's optics. And this is day 1. And the topic today will be, what did I call it? Reflection. And if we add another topic, I'll come back and add something to that. So, and well, there won't be any homework today. All right, so you can make your own little chart as if I gave you a handout. And the notes can follow. And so set up your notebook so that you have a divider for the next mod. Mod 11, again, is optics. All right, let's go ahead and find out the basics about the behavior of light. And we're going to look at the behavior as light is a light beam, which is a beam of particles. So what we'll observe is when light is acting like a particle. So we know it doesn't always act that way, but that's how we're going to look at it during this mod. And when it's acting like a particle, its behavior is called optics. And this light behavior is our focus of study. The first thing I want to look at is the law of reflection. And if I write it down, you write it down. I've got notes, you've got notes. Law of reflection. So we'll come back and fill that in, so just leave a spot. Let's talk about it. Say we have a mirror. And as a beam of light comes in and hits the mirror, so this is light coming in, it creates an angle with the mirror. So I'm going to put down the angle right there, the symbol, the typical symbol for angle, theta, and then the mirror, because of its properties, will not absorb it, it will reflect it, and it goes off, lo and behold, at the same angle. So that is called the law of reflection. We state it like this: we call this angle, when the light beam is coming in to the reflective surface, we call it the angle of incidence, I-N-C-I-D-E-N-C-E, incidence. So the angle of incidence, and we call this angle, after it hits the reflective surface, we call it the angle of reflection. So when we discuss the law of reflection, we say the angle of incidence equals the angle of reflection. All right, the angle of incidence equals the angle of reflection. That is what we're going to say is the law of reflection. I'm sure that's not too shocking. Seems to be part of our experience. We've seen that kind of behavior. We'll go ahead and experiment with that. It's not going to be a real technical experiment, but we will go ahead and demonstrate that together when I return. All right, let's take it a step further. Let's see if you can follow this. We will have a mirror. This time the mirror is like on a wall, and we have somebody in front of the mirror. Let's just say there's a foot. So I've got a big toe, and second toe, third toe, fourth toe, and little baby toe. All right, so, and I'm emphasizing the big toe, you can see. And the way we see the big toe in the mirror is quite interesting. What happens is we only see this toe because light is being reflected off of it, and the light is going in all angles. But there's one beam, here's your eyeball looking into the mirror. There's only one light beam that will come off of the toe in such an angle, and the angle of incidence has to equal the angle of reflection. So we've got to find one light beam that follows that law and reaches your eye. So I'll see if I can find it. So angle of incidence, that would be the angle of reflection. That looks about right. So the angle of incidence from the light beam is going to bounce off of the toe, come into the mirror, create this angle, and reflect. That's supposed to be at the same angle, and it will hit your eye. So one light beam will do that. Now, what the brain observes, kind of interesting. Well, we'll go ahead and finish this. Let's say the little toe. So there's light coming and reflecting off of the toe. Little toe. So here's the eyeball. So I'm gonna pick one that has the right angle. So maybe this one. All right, that looks about right. Like this angle equals this angle. All right, so I have two beams of light. One is showing me the big toe, and one is showing me the little toe. And of course, there's a lot more, but I am going to take these two to make a point. Here's the one from the big toe, and what the brain does, it doesn't recognize this reflective bend here. The brain is situated in these things to think that light is always traveling in a straight line. So what it does, and we know it's not really happening, but it extrapolates. It thinks that the light that reflected off this surface came from a straight line, and that part that I'm talking about is called the extrapolated ray. So it doesn't really exist, but the brain goes ahead and acts like it does. So it has this part, it sees this part that's really in front back here. So there's my big toe. All right. So that's what it's seeing or thinking, and it's from an extrapolated ray. So as the eyeball extrapolates this ray backwards in a straight line, then it also does the same thing for the little toe. And see, the little toe was this line. So it's going to extrapolate back here. And the little toe will be here. So, and then it'll do the same for the other four toes, and lo and behold, you see the foot. However, it's supposed to look identical. This, you'll notice, is a right foot, but this, because of how that extrapolation worked, is a left foot. So that's why everything looks backwards in the mirror, to you or to you. Your left looks like your right, and your right looks like your left. So that is how the law of reflection will help us see objects, and how the brain and the eye extrapolates those reflections backwards into the mirror. So that's when you look in, and if you look at a mirror, it looks like you're looking into it or almost behind it. That's why the image looks like it's inside or behind the mirror, because of this extrapolation. So, very interesting. All right, an image formed by extrapolated rays. This is important. Let me get this straight. All right, an image formed by extrapolated rays is called a virtual image. So an image formed by extrapolated rays, like the foot, is called a virtual image. All right. So once you have those notes down, you can proceed to the next video.